Good morning, guys. This is for academic on Tuesday the 25th. A lot of band kids are probably watching this, so hopefully you got the notes from your teacher, but if not, you can print them off of Canvas on today's model. This is the warm-up for today. You need to pause and then play when you're ready to go over it. What you're doing is just to write the each number as the product of two whole numbers. So like what are its factors? Remember, there can be multiple ways to do a few of these, so do as many as possible. Okay? Again, pause. All right, what are some factors of 6, Kyle? 3 and 2. Good. Rory, what's another one? And very good. For 16, Natalia, what are some factors? 4 times 4. Lana, do you know another set that can get you 16? What? She said 4 times 4. What's another set of numbers that can get you 16? 2 times 8, very good. Jackson? 1 times 16. Hey, it absolutely works. All right, Sal, did you get 1 for 17? Okay, can someone help her out, Kennedy? 1 times 17, a number in itself. Great. There's no other factors, no other whole numbers. And then 36, there's quite a few for 36. Jackson, do you have 1 for 36? 1 times 36, hey, it works. Lucy? 6 times 6, there's one other one. 4 times 9, all right? So if you missed any of those, they are under here. So, 2 times 16, we've got that one as well, okay? Because it is an odd, or sorry, it's an even number. As I was just telling my class guys on the recording, today's going to be a big day on knowing your multiplication facts and your divisibility rules, okay? We did an ELT lesson back in the first semester where we talked about the different divisibility rules. We hope we have that covered in our resource section of our binders, but we'll sort of go through them today. I do have a divisibility rule. I have posters in my room. I'm not sure about the other teachers, but those are always good to keep in handy in our brain, in our tool belt of life. Okay? So, let's first go over our homework sheet. Up in the recording, I'm going to pause this because you'll just check on me. All right, so here we go with the lesson today. So we're going to be talking about prime factorization, and someone in my warm-up already said the word prime. Do y'all know what it means to be a prime number? Yes.
It's only divisible by itself if the only factors are 1 and it's
very good. So we're going to be talking about first what it needs to be prime versus what it needs to be composite. It defines it right here. So I don't know, some people like to highlight, but you could highlight that prime number has only 2 factors being 1 in itself. Okay, you technically can make the argument that any number is divisible by any number where it gets into decimals and fractions and blah. But we're talking about whole numbers where only 2 factors are 1 in itself. So, for example, the number 5. What are the 2 factors of 5? 5 and 1, 1 and 5. Okay, 17. We already saw 1 and 17. Okay, 23 would be 1 and 23. Okay, so just like numbers can be classified as odd or even, numbers can be prime or composite. Okay, there are a few exceptions to those rules, but for a majority of, like, all but 2 numbers are either prime or composite. Okay, so let's look at some composite numbers. Again, it has more than 2 factors. So for 12, I'm going to do it in pairs. Some people write it differently. What are some factors of 12?
1 and 12.
1 and 12. What's another pair of numbers?
4.
Other than Kennedy, what's another set?
6 and 2.
6 and 2. Anything else?
2.
We already said 2. Okay, we did pairs and stuff like that. Very good. All right, 15. Kyle, what are 2 factors of 15?
1 and 15.
1 and 15. Very good. Lana, do you know another set? We already said 15. 5. And very good. 3 and 5. Good. All right. 24. Cameron, give me a set of numbers that gets me 24. 4 times 6. Awesome. What's another set, Rory? 3 and 8. What's another set, Lucy? 1. Huh? 2 and 12, very good. And then everyone's favorite.
6 and 4.
Oh, we already said 6 and 4. 1 and 24. All right. So a cute little way. You do not have to think. This isn't the end all be all way, but this is a cute little thing that I saw one time. To remember what a prime number is. Okay, watch how you write it. Cute. For prime, it's 1 and me. And you see how it spells prime? And it's 1 and me. Those are the factors of prime numbers. Y'all see it? 1 and me.
That is so
cute. Oh my God, hold on. Okay. Alrighty. Okay. So let us continue on. So we're just going to practice and say whether it is prime or composite. For each of these numbers, put a P for prime, C for composite. I'll give you a few seconds. Okay, if y'all want to do one together or no?
Yes, please.
Okay, 35.
Composite.
What is a hint that it's going to be a composite number? It ends in 5, so I already know it's going to be composite. Do the rest. Pause and play when you're ready. All right. So here we go. Again, this is going to be where divisibility rules really help. I know, so let's take a quick pause. If a number is even, 2, 4, 6, 8, 10, it ends in 2, 4, 6, 8, 4, 0. I know class that it's going to be divisible by 2. Okay? I know if it ends in a 5 or a 0, that number is divisible by 5. If it ends just in a 0, it's going to be divisible by 10. Let's take a pause. Do y'all remember the rules of 3 or 9?
If you add them together, they're divisible by 3.
If you add up the digits, so like if I had the number, I'm going to use one that I know, 27. If I add those digits, 2 plus 7 equals 9. If that is divisible by 3, it's divisible by 3. The whole number is divisible by 3. If that sum is also divisible by 9, it's also divisible by 9. Okay, those things are very valuable to know. So let's go through this together. And some of this we might have to guess. Usually I'll test it out with like 2, 3, 4, 5, all the way up to 9. And if I can't get it, I'm like, probably not. Okay, so like 29, prime or composite? Prime, very good. 130, composite. Raise your hand. What are some numbers I know I can divide it by? Lauren, what's 1? I can divide it by 10. I can divide it by 5. Yes? 2. What else? 13, because of that 10. Is that 13? 65. Okay, yeah. So there's lots. Some of them are more natural than others. Like 13 is not one I know off of hand, but I do acknowledge that it does work. All right, 42 class is composite. What are some factors? 2, 6, 7. Okay, as long as you think of any number besides 1 in itself, it's going to be composite. 19, prime, and 31. Prime. Very good. Okay, so now let's take a pause. There are a few exceptions to the rules. Okay, let's talk about 1. Okay, what about 1? And I want y'all to please put this on your paper. Okay, ask yourself, what about 1? It's going to be prime, it's going to be composite, why? Okay, think about prime.
What about 1?
What about 1? Okay, take a second, make a decision, have an organic 1. What do we think? Why? Oh, you have to have a reason why. What do y'all think?
I think it's I would say composite.
Okay, why?
No, it's fine.
Okay, Rory?
I think it's fun because it's lowest of all numbers, so no higher number can go above it.
Okay, Kimby?
I think it's neither because if I was multiply 1 by 1, it's 1, and that's 1.
And Lana?
I also think it's neither because if you do 1 times 10,
Yeah.
it's currently whatever else.
Okay, so let's go back to the definition of both of them. Prime, it says it has how many factors?
I'm in
2 or
Prime says it has 2 factors. Let's list off the factors of 1. What times what gets you 1?
1.
It's just 1. 1 times 1 gets you 1. 1 times anything else does not get you 1. Okay? So the only factor of 1 is 1. So that doesn't fall under this because it says that it has to have two factors. This one has more than two factors. So one is an exception to the rule. Okay, so if you don't said neither, that is correct. Okay, what about one? It is neither because it only has one factor. It only has one factor. Let's talk about zero then. Okay, do you think zero would be prime, composite, or neither? And why? Let's take a guess. Boys, you know how to guess? Would zero be prime, composite, or neither? I see you thinking.
Zero would
Why?
because it is, you could do 1 or 0.
Okay, Kyle.
I think it would be also neither.
Because
Because like I was saying before, 1 is one of the lowest numbers and 0 is kind of below that, so you can't have any more.
okay, so I'm just gonna cut to the chase. For zero, it is also neither, and the reason is because it has infinite things. Okay, it has infinite factors. The limit does not exist. Okay, so zero is also neither. Because it has infinite factors. It could be 0 times literally bajillion, bajillion, bazillion, whatever number you want to come up with. Okay, or 5. Okay? All right, so we're going to use that understanding of prime and composite numbers, and we're going to do what's called prime factorization, where we take composite numbers and we break it down into its prime numbers. Okay, so let's take a look at that. Let's break down the word prime factorization. Prime, we just said, means that the only factors are 1 in itself. And then factorization, what operation do we apply with factoring? Multiplication. Whenever we hear the word factor, we think of multiplication. So in order to do prime factorization, we write the number and we are going to create a tree diagram. This is sort of what we can call it. Okay, we write down a number being factored at the top and we choose a pair of factors. We're going to break those numbers down until they are all prime. So what do I mean by that? Let's take the number 36. What two numbers could I multiply, Brody, to get 36? What two numbers can I multiply to get 36?
1 is 36.
I want something that's not going to help me.
2
And 18, right? Okay, y'all ready? Okay, so what we're going to do, we're going to break it down into two factors. 2 times 18, y'all agree, equals 36? Yes. Okay, is either one of those numbers a prime number? Is 2 a prime number? Yes. Is 18 a prime number? No. So I can break 18 down further, but with 2, I'm going to pause. All right, so I'm going to break down any number that I can, but if it's prime, what I'm going to do is I'm going to circle it. Okay, saying that's going to be my stopping point. 2 is prime, but 18 I can break down into what two numbers?
2 and 8.
I can do 2 and 8, 2 and 9, yeah, correct. 2 and 9, 2 is prime. 9 I can break down into
3 and 3.
3 and 3. Is 3 prime?
Yes.
Yeah, both of those are prime. Okay, so I wrote down the number, I chose a pair of factors, and I factored until all the numbers are prime. Now what I need to do is write the expression using all prime numbers. Okay, so again, I have all these prime numbers, 2, 2, 3, and 3. And so I'm going to write it as a factor sentence. So I could say that 36 is equal to 2 times 2 times 3 times 3. Y'all agree with that statement? Okay, because let's check. 2 times 2 is? 4 times 3 is?
12.
And 12 times 3 is? 36. That's correct. But let's take it back to yesterday. Yesterday, we talked about like repeated multiplication. Whenever I do like 2 times 2 times 2 times 2 times 2, there's another way I can write that. I can shorten that up. What did we talk about yesterday, guys? Exponents. So I can write this also using exponents. So if I have 2 times 2, another way of writing that is 2 to the power of 2. Okay, I can combine these two, but then I can also combine those two. I would say 3 to the power of 2. Okay, times 3 to the power of 2. So go ahead and rewrite that. Okay, when we do prime factorization, we want to break it down into its prime numbers, and then we're going to use exponents to write it out. Okay, take a pause, digest it. We'll do another one in a second. All right, so let's do 70. Rory, what do you want to break it down by?
10.
Let's break it down in 10 and 7. I'm going to put a little line to break it down. So 10 and 7. Are either one of those prime class? 7 is prime, so I'm going to circle it. 10, what can I break it down into? 2 and 5. It doesn't matter which one you do. Okay, it's 2 prime?
Yes.
It's 5 prime?
Yes.
Yes. So I'm done. Now I'm going to rewrite it. Okay? Something I didn't mention before is we always like to do our factors in increase order, starting from smallest going up to largest. So my 3 factors, I have 2. Again, what operation am I doing? Times 5 times 7. Are there any exponents that I could write in those? Is there anything I could crunch? If I were to add an exponent, what exponent could I add to each of those? Lucy.
2, 1.
I could put a 1 with each of them, but it's not necessary. But if you wanted to, that is what you could do. Okay? Now we're going to take a pause because Rory had said earlier, she said 70, that's divisible by 10, but it's also divisible by 5. Let's see if that changes the answer at all. Okay? So I'm going to leave that one there. You don't have to write this. You can just watch for this one. So if I started with 70, she said I could break that into 5. Don't know what 5 times what gives me 70? If we didn't know, what could we do? Divide it out, okay? Again, you might not know both of the factors, but you might be able to tell, hey, I know it's divisible by 5. Solve it out. 5 goes into 7. 1 time, 5. I get 2 left over. Bring down that 0. 5 goes in. 4 times to give me 20. So you were right with that 14. But again, I want you to know you can always solve it out. All right, is 5 or 14 prime? 5 is, so I'm going to circle it. 14, I can break down into 7 and 2. Both of those are prime. Does that give me the same answer?
Yes.
Yes. Okay. So that's the beautiful thing about prime factorization. It could look completely different, but you should end up with the same answers. Okay. So go ahead and do 45 on your own. Break it down, see what you get, and then we'll come together. If you're at home, pause and play when you're ready. Brody, what did you break 45 down into? Jackson, what did you break 45 down into?
I was gonna say maybe 4 and 10.
4 and 10 only gives me 40. Brody.
2 and 20.
That also gets me 40. Sheetha. 5 and 9. We need 2 numbers that multiply to get me there. So 5 and 9. Okay? Are either one of those prime?
Yes.
Which one? 5 is prime, but 9 I can break down. I can break it down into 3 and 3. Okay? So again, that's the same thing as 3 times 3 times 5, but I want to shorten it as much as I can. So, Kennedy.
3 squared times 5.
3 squared, 3 to the power of 2, because there's 2 of them, times 5. Again, that would be 3 times 3 times 5, but because there's a repeated, you can square it. Are y'all good with that?
Yeah.
Okay. So, I think I'm going to let y'all do a little bit on your own. Okay, so on that next page, it says find 2 different possible factor trees for 60. Okay, so you're going to have 60, you're going to break it down. You're going to do it a different way. Okay, so maybe you pick 2 factors, but pick 2 different factors. Go ahead and do that page. I'm going to give you probably about 10 or so minutes. You can work with a partner. In a few minutes, we'll come back and we'll check that together. Okay, ready, set, go. Okay, for 70, I saw quite a few, 60, I saw lots do 10 and 6. Are either of those prime? No, so keep breaking it down. 10 can be
2 and 5.
2 and 5. 6 can be
2 and 3.
2 and 3. Are any of those composite?
No.
No, so that is going to be my final thing. Again, when I rewrite it, I want to group like with like. So I see how many 2s?
2.
I have 2 to the power of 2. How many? I go to 3 next. How many 3s do I have? 1, and then just 1 5. If you rearrange the order of the numbers, that is fine, but the exponents have to be the same. Okay? Let's keep moving. 23, was it prime or composite? Prime, 45. Composite, a hint is that it ends in a 5. 112 is composite. It's an even number, so you can divide it by 2. 144, composite, 0, neither, and 1, neither. Okay, then I had some people, it was different numbers that were giving you stuff, and again, the divisibility rules help. It won't always be the biggest numbers, but sometimes it can help you. What do we notice about 54 that can help us break it down? The 4 means that it's going to be divisible by 2. If it's an even number, I can divide it by 2. Okay, you might have to figure out what that other factor is, which is 27, and then it's up to you to go from there. 27, what can I break that into?
3 and 9.
3 and 9. Is 3 prime?
Yes.
What about 9?
No.
Break it down into 3 and 3. Okay? So let's rewrite that. Who wants to take a chance?
Oh, would it just be like 2 times 3 times 3
2 times 3
times 3?
times 3 times 3, yes, but I instead want to say power 3 or cube because there's 3 of them. Okay? Those little divisibility rules really help. So here are the answers for the rest of that page that you can check. Let's talk about number 7 real quick, because this is my favorite kind of test question, because it basically can be the answer. On number 7, it asks you which one is the prime factorization. Before I even solve the problem, what I usually do is say, hey, if it's not prime numbers, it's not the prime factorization. So let's look at what it underlines. Okay? 3 times 10 times 25 is 10 prime. No, I can eliminate that answer. In D, which one's not prime? 6. Above that. In D, what's not prime? D. Okay? Now, in test questions, they might not have it where all of them are not equal, or sorry, they might have a few answer choices where there's all prime numbers, but this is an easy way. How else could I check? If I didn't want to do my factor tree, do y'all know how I could check to see if this answer is equivalent, is equal? Could I multiply this out? Could I do 2 times 3?
Yes.
What does that give me?
6.
6. And then I can multiply that times whatever 5 times 5 times 5 is. It's not 35, but you would multiply it out. Okay? You can break down the number, but I'm just talking about testing strategies. Your homework is to finish, I guess, one part. Let's look at what that is.
Wait, do we have to finish?
Let's do the odds. Let's do the odds. Y'all have a good afternoon. Thank you and good night.